Can the CU use the main computer RAM as an extension? I have a laptop with a dedicated CU NVIDIA Quadro P3200. It has 6 GB of RAM. The laptop also has 32 GB of normal CPU RAM. I'm planning on using the CU for parallel computing, running physics simulations. Some of these involve quite big arrays. I'm just wondering if the total memory, all the variables and all the arrays, in my kernel hits 6 GB of the CU RAM, can I somehow use the CPU's one? I would not be using the laptop for anything else during the computation, so the main RAM should not be busy. PS I am using a Dell Precision 7530, Windows 10.
Short answer, no, you can't. Longer answer. The bandwidth, and more importantly, latency between the CU and RAM over the PCI bus is an order of magnitude worse than between the CU and VRAM, so if you are going to do that you might as well be number crunching on the CPU. CPU can use a part of VRAM, part mapped into the PCI aperture, usually 256 MB, directly as RAM, but it will be slower than regular RAM because PCI is a bottleneck. Using it for something like swap might be feasible. It used to be possible to increase the memory aperture size by changing the strap bits on the CU BIOS, but I haven't tried this since NVIDIA Fermi, GeForce 4XX, CUS. If it still works, it is also required that your BIOS is up to the task of mapping apertures bigger than standard. It is highly unlikely to have ever been tested on a laptop. For example, a Xeon Phi compute card needs to map its entire RAM into the PCI aperture, so it needs a 64-bit capable BIOS and a host that knows how to map apertures above the traditional 4 GB, 32-bit, boundary.
Yes. This is the shared memory between the CPU and CU, and there is always going to be a small amount required as buffers to transfer data at the CU, but it can also be used as a slower backing to the graphics card in much the same way as a page file is a slower backing store to your main memory. You can find shared memory in use in the built-in Windows Task Manager by going to the Performance tab and clicking on your CU. Shared memory will be slower than your CU memory though, but probably faster than your disk. Shared memory will be your CPU memory, which may operate up to 30 GB/s on a reasonably new machine, but your CU memory is probably able to do 256 GB/s or more. You will also be limited by the link between your CU and CPU, the PCI bridge. That may be your limiting factor, and you will need to know whether you have a Gen 3 or Gen 4 PCI and how many lanes, usually x16, it is using to find out total theoretical bandwidth between CPU and CU memory.
As far as I know, you can share the host RAM as long as it is page-locked, pinned, memory. In that case, data transfer will be much faster because you don't need to explicitly transfer data, you just need to make sure that you synchronize your work, with CUDA synchronize for instance, if using CUDA. Now, for this question. I am just wondering, if the total memory, all the variables and all the arrays, in my kernel hits 6 GB of the CU RAM, can I somehow use the CPU's one? I don't know if there is a way to extend the CU memory. I don't think the CU can use pinned memory that is bigger than its own, but I am not certain. What I think you could do in this case is to work in batches. Can your work be distributed so that you only work on 6 GB at a time, save the result, and work on another 6 GB? In that case, then working in batches might be a solution. For example, you could implement a simple batching scheme like this.
Any POO can use system RAM when running out of its own VRAM. In a similar manner to running out of RAM on a system and paging all excess data to storage units, SSD/HDD, modern PIS can and will pull textures or other data from system RAM. Texture data can be used from system RAM over the PSI bus to make up for the lack of the faster VRAM. Since system RAM is a few times slower than VRAM and has much higher latency, running out of VRAM would translate into a performance loss, and the performance will be limited also by the PSI bandwidth. So it's not a matter if there is possible or not, it's a matter of performance when doing it. Also note that many integrated PIS use system RAM, do not even have their own. In the case of PIS, the main factor in their performance is the software. A well-designed software will use the POO near its output flops limits, while one designed badly will not. Usually the computing and hashing software comes in the first category. Same goes for allocating VRAM.
If you want to support the channel, please consider subscribing.